Our neighboring galaxy Andromeda is currently posing a huge mystery to astronomers. Just like our Milky Way, Andromeda is surrounded by a whole cart of smaller dwarf galaxies, but now experts have discovered something that, in this form, should not exist at all. In fact, Andromeda's companions exhibit a confusing one-sided distribution. We have no idea what this strong asymmetry is all about, researchers admit. In fact, experts have not even been able to reproduce this one-sidedness in their simulations. Today, we'll show you what researchers have discovered about the impossible arrangement of dwarf galaxies and why it's shaking our standard model of cosmology. The Andromeda Galaxy, M31, is located about 2.5 million light-years away from our Milky Way. What may sound like an unimaginably large distance at first glance is so close together in astronomical terms that the halos of both galaxies even touch each other. As a result, we can also see our galactic neighbor as a faint, blurred spot of light in the night sky and marvel at a structure that looks back on a similarly eventful past as our home galaxy. While Andromeda has a mass comparable to that of the Milky Way, it too has a history of numerous collisions and mergers. Another similarity between the two galaxies is that they are not alone. Both the Milky Way and Andromeda are orbited by numerous smaller dwarf galaxies. These are mainly remnants of earlier mergers that caused the larger galaxies to grow. According to our standard model of cosmology, the galactic dwarfs should actually orbit their significantly more massive host galaxies in an almost random arrangement. Well, actually, because in the case of Andromeda, this is simply not true. Osuke Jamie Kanehisa from the Leibniz Institute for Astrophysics in Potsdam and his colleagues explain, the dwarf galaxies observed around our neighboring galaxy Andromeda contradict this expectation because they are highly skewed. In detail, this galactic imbalance means that the majority of Andromeda's dwarf galaxies are concentrated on just one side of our galactic neighbor. But what is actually going on here? Well, that's exactly what Kanehisa and his team of experts wanted to find out when they examined a new dataset on the positions and distances of 37 satellite galaxies. Indeed, the new analysis confirmed the puzzling asymmetry. With only one exception, all of Andromeda's companions are clustered within a 107 degrees cone pointing toward the Milky Way. In other words, the dwarf galaxies are distributed over only 64% of the entire Andromeda orbit. Even more confusing, however, is the fact that half of the satellite galaxies orbit Andromeda on the same plane, similar to the planets orbiting the Sun. The researchers say that the combination of such a plane of companion galaxies and a skewed arrangement is extremely unusual from a cosmological point of view. This inevitably raises a question of whether Andromeda's dwarf galaxies represent an exceptional outlier or whether our understanding of galaxy formation on small scales is fundamentally flawed. The asymmetrical distribution is hardly reproducible. To find out which of the two cases applies and to gather further insights into the possible causes and frequency of such asymmetrical distributions, Kanehisa's research group used simulations of galaxy evolution. Co-author Marcel Pawlowski explains, using two known simulations, we searched for Andromeda-like host galaxies and analyzed the spatial distribution of their dwarf satellites using special metrics to quantify the asymmetry. The bottom line was a confusing result. Such an asymmetrical distribution of dwarf galaxies is hardly reproducible, even in similar galaxy pairs such as Andromeda and the Milky Way. In detail, the experts had to look at more than 300 simulated systems to find just one that is as extremely asymmetrical as Andromeda. Conversely, this means that our galactic neighbor, with a constellation of its companions, is an absolute outlier that stands in stark contrast to our cosmological expectations. And so it is that Kanehisa can be quoted as saying, "Our analyses show that such a pattern is extremely rare in current cosmological simulations." But why is this the case? What causes a vast majority of Andromeda's satellite galaxies to be so unevenly distributed? After all, less than 0.3% of all comparable galaxies show such asymmetry. Well, the short, yet unsatisfying, answer is that we simply don't know yet. One possible explanation is based on the assumption that Andromeda acquired a whole cluster of these dwarf galaxies in one fell swoop a relatively short time ago. At the same time, however, it could also be that we are contributing to this cosmic mystery. It's conceivable that the gravitational influence of the nearby Milky Way plays a role here, even if this has already been taken into account in the simulations. Ultimately, however, the experts have no choice but to draw the following not particularly insightful interim conclusion. At present, No known formation mechanism can explain the collective asymmetry of the Andromeda system. But perhaps the emphasis in this case really is on the word "at present." Scientists now hope to find other galaxies with similarly asymmetrical dwarf galaxy distributions in order to shed more light on the causes of this unexpected constellation. In fact, astronomers have already begun their search of galactic outliers, and future surveys, primarily those conducted with the Euclid Space Telescope, are expected to significantly accelerate the search. Until then, however, the experts are not condemned to sit idly by and twiddle their thumbs. After all, in the meantime, they could take a closer look at a very specific companion to Andromeda that challenges our models of star formation in small galaxies. Why Andromeda's companion is puzzling experts. It's not always easy to add the dwarf companions of mature galaxies to star maps, as they are not only significantly smaller, but also less luminous than their more massive counterparts. However, a research team led by José Martínez Alvarez from the University of Michigan recently succeeded in discovering another Andromeda satellite galaxy that had revealed itself in the data of the Pan-Andromeda Archaeological Survey. This is another sky survey that was completed between 2008 and 2011 using the Canada-France-Hawaii telescope. After the object in question was tracked down and named Andromeda 35, subsequent investigation by the Hubble Space Telescope revealed that it's indeed a dwarf galaxy, and one that truly deserves the title dwarf. This structure has a star mass that is just 15 millionths of the star mass of Andromeda. However, Andromeda 35 is not only extremely small, it also shines more dimly than all of Andromeda's galaxy companions discovered to date. As a result, the newly discovered object is also the first satellite galaxy beyond our own that is as small and faint as galactic satellites of the Milky Way. However, that is where the similarities end, because apart from its comparable dimensions, Andromeda 35 has one major difference. In most of the Milky Way satellite galaxies, no new stars have been born for around 10 billion years. But in Andromeda 35, stellar production only ceased around 6 billion years ago. Until then, researchers had assumed that the universe must have been very hot at that time due to bright stars and voracious black holes. According to this theory, small galaxies such as Andromeda 35, which comprise less than 100,000 solar masses, should have lost the gas needed for new stars to form. However, this was apparently not the case for the satellite galaxy that has now been discovered. But why this is so remains an unsolved mystery for the time being. It seems that the processes at that time were more complex than previously assumed, and experts are now pinning their hopes on the James Webb and Nancy Grace Roman telescopes, which are set to investigate the mystery of star formation that occurred much too late. ### will we merge with Andromeda after all? But who knows? Maybe in the distant future, it will be much easier to unravel the mysteries of the Andromeda Galaxy simply because it will be part of us. Or will it? You've probably heard that in around 4 billion years, the Milky Way will collide with Andromeda, forming a new elliptical galaxy. In fact, this predicted event is now so firmly established in the world of astronomy that we even have a name for the galactic fusion product, Milkdromeda. But what if the merger of worlds doesn't happen after all? Well, new models have shown that this is not so unlikely after all. In fact, we should not forget that there are other nearby galaxies in the local group, our higher-level galaxy cluster, including the Large Magellanic Cloud and the Triangulum Galaxy M33. Added to this is the fact that some galaxy masses in the local group have now been remeasured, and the new values consequently also influence their orbits and gravitational effects. Against this backdrop, a team led by Till Sorala from the University of Helsinki has re-examined the predicted Andromeda-Milky Way collision in more detail using a computer model, and found that the galactic crash is less likely than previously thought. This is because when we take all four players into account, for example, the Milky Way, Andromeda, M33, and the Large Magellanic Cloud, the probability of collision is only slightly more than 50%. This is due to the fact that the Large Magellanic Cloud is moving perpendicular to the course of the Milky Way and Andromeda, and when it encounters our home galaxy, it will probably deflect it. In concrete terms, this means that the future existence of Milkdromeda is anything but certain, but ultimately just as likely as a scenario in which Andromeda and the Milky Way do not collide. And our experts have calculated that the probability of your click colliding with the subscribe button is 100%. Go ahead and hit the thumbs up and subscribe buttons so you never miss another video from us again. We'll see you soon.